On this slide, we're introducing DNS over HTTPS, commonly abbreviated as DoH. DoH is a protocol designed to perform remote DNS resolution through the HTTPS protocol. The primary purpose of DoH is to enhance user privacy and security. It achieves this by encrypting DNS queries, which prevents eavesdropping and data manipulation. These key benefits make DoH a significant tool in safeguarding your online activities from unwanted surveillance and ensuring your data remains intact during transmission. Why DNS over HTTPS matters can be broken down into two major areas: privacy and security enhancement. Firstly, in terms of privacy enhancement, DNS over HTTPS encrypts your DNS queries. This encryption plays a vital role in masking your web browsing habits from third parties, making it significantly harder for anyone to track which websites you are visiting. Secondly, from a security improvement perspective, DNS over HTTPS mitigates man-in-the-middle attacks. By ensuring that data passed through DNS queries is encrypted via HTTPS, it protects the integrity of the data, preventing unauthorized manipulation and providing a more secure browsing experience. Let's dive into the technical details of DNS over HTTPS, DoH. Starting with how it works, DoH encapsulates DNS queries within HTTPS traffic. This setup ensures that the queries travel securely through an encrypted channel. By utilizing TCP port 443, which is also used for standard HTTPS traffic, it's able to blend in seamlessly with regular web traffic. Regarding standards, DNS over HTTPS was officially published as RFC 8484 in October 2018. It's recommended to use the HTTP2 protocol at a minimum, which offers performance improvements over its predecessor, HTTP 1.1, further enhancing efficiency and reliability in DNS query handling. All these elements combine to provide a robust mechanism for securing DNS queries and improving overall privacy and security on the Internet. In this slide, we will discuss popular providers that offer DNS over HTTPS services. Some of the leading providers include Google DNS, Cloudflare DNS, and Quad9 DNS. Each of these providers offers an endpoint to query DNS over HTTPS. For example, Google's endpoint is available at https:/dns.google/query, while Cloudflare's is at cloudflare/dns-query, and Quad9's can be reached at hdns.quad9.net/dns-query. You can use command line tools like curl to make DNS queries to these providers. For Google, you could use the command curl h accept application DNS message hts/dns.google/query DNS encoded query. And for Cloudflare, you would use curl 8 accept application DNS message cloudflare dns.com's DNS query DNS encoded query. These commands encapsulate your DNS queries within HTTPS requests, ensuring privacy and security. This effectively obfuscates your DNS query from potential eavesdroppers, leveraging the security benefits of HTTPS. This slide focuses on different deployment scenarios for DNS over HTTPS, DoH. We are looking at two primary contexts for using DoH: within applications and through network proxies on local systems. Firstly, consider using DoH within applications. Modern browsers like Chrome and Firefox come with built-in DoH support, allowing for seamless, transparent implementation for users. This means that without additional configuration, your browser can make secure DNS queries. Next, we have network proxies on local systems. Tools like Cloudflare can set up a DoH proxy on your local network, centralizing DNS resolution. This approach is particularly beneficial for larger environments. An example command to run a DoH proxy would be Cloudflare proxy DNS port 553 upstream h/1.11.1's DNS-query. This command sets up a local proxy on port 553 that forwards DNS queries to an upstream DoH provider. Understanding these deployment scenarios will help you choose the best approach for your specific needs, whether it's configuring DNS for individual applications or managing it centrally in a networked environment. In this slide, we're focusing on software support for DoH, specifically within browsers and operating systems. When it comes to browsers, Google Chrome, starting from version 83, allows you to configure DoH via the Settings menu. Mozilla Firefox has made DoH the default in the US, and you can adjust the settings as needed through the Settings menu. Microsoft Edge also supports DoH, which can be enabled through its settings. Operating systems also offer varying levels of support. Windows introduced initial support for DoH in Windows 10 and provides full support in Windows 11. macOS has supported DoH starting from version 11. For enabling DoH in Google Chrome, you would navigate to Chrome/settings/security, enable Use Secure DNS, and then choose Cloudflare 1.11.1 for your secure DNS provider. This setup helps to ensure your DNS queries are encrypted and more secure. Let's move on to the potential security considerations you'll need to be aware of when using DoH. Security considerations are a vital aspect of DNS over HTTPS DoH implementation. While DoH encrypts DNS traffic, making it harder for unauthorized parties to monitor, it's not infallible. Therefore, we encounter challenges such as ensuring the integrity of the DoH server. The client has to trust the DoH server to accurately validate and respond to DNS queries. To enhance security, it is recommended to combine DoH with DNSSEC, which provides end-to-end security by ensuring that DNS responses are not tampered with. Additionally, robust server authentication, using mechanisms like X509 certificates, ensures that communication is established with legitimate servers. These practices help mitigate potential risks associated with DNS traffic analysis and server integrity, bolstering overall network security. Enabling DNS over HTTPS in Firefox. To enhance your browsing security by enabling DNS over HTTPS in Firefox, follow these steps. 1. Open Settings. Navigate to the Firefox settings and select Privacy and Security. 2. Scroll to enable DNS over HTTPS. Look for the specific option to enable DNS over HTTPS within the privacy settings. 3. Choose a provider. You will need to select a trusted provider, such as Cloudflare. 4. Set protection level preferred. Adjust the level of protection to match your security needs. Additionally, for more advanced users, you can configure DNS over HTTPS through the About Config page. Set network.mode to 2 and network.tr.uri dns.quad.net/dns-query to specify your DNS server. These steps make your DNS queries more secure and protect your browsing data from eavesdropping and tampering. In this slide, we will focus on testing and validating that DNS over HTTPS, DoH, is functioning correctly. To do this, we can use network diagnostic tools such as DIG or KDIG. These tools allow you to verify the performance and reliability of your DoH configuration. For example, you can run the following command: dig +short@127.p-fif3 example.com. This command queries the DoH service running on your local machine. It checks whether the response times have been reduced, which can help improve the end-user experience. Furthermore, the DNS results obtained from these tests should be consistent with those from normal DNS queries. This consistency validates that the DoH setup is correctly handling DNS queries. By performing these tests, you can ensure that your DoH implementation is both efficient and reliable, providing a secure browsing experience for end users. Now, let's discuss some deployment tips for implementing DNS over HTTPS, DoH. Firstly, consider using local DoH proxies. Tools like Cloudflare can efficiently handle this. You can enable and start Cloudflare with the following commands: sudo systemctl enable Cloudflare, sudo systemctl start Cloudflare. Next, pay attention to your firewall configuration. Ensure that there are no conflicts, especially related to SSL/TLS inspection rules. Configuring your firewall properly is essential to avoid disruptions and maintain a secure environment. By properly deploying DoH with these steps, you'll help ensure a smoother and more secure integration into your existing network infrastructure. In conclusion, DNS over HTTPS provides a significant enhancement to privacy and security by protecting DNS queries from being observed or tampered with. It's highly recommended to integrate DoH with DNSSEC for a more robust DNS security posture. Regular validation of your setup is essential to ensure that everything functions optimally. Going forward, keep yourself informed by staying updated with the relevant RFCs and the latest implementations in DNS security. For further reading and to deepen your understanding, let's turn to the references that will guide your implementation of DNS over HTTPS. Firstly, RFC 8484 provides detailed technical specifications. This document is essential for grasping the underlying protocols and ensuring compliant implementation. IETF Documents offer guidelines for the secure deployment of DoH. Following these recommendations will help maintain the security and efficiency of your setup. Lastly, browser documentation from major web browsers like Chrome and Firefox outlines specific configurations. These resources are invaluable for integrating DoH into your everyday browsing environment effectively.